Okay guys, just before I go ahead and set up to do this bore on the back end, because we're going to be boring from the front through to the back, I'd like to use this pre-bore that we've done as a concentric reference to set up to clock up to. So I just want to see where that bore is in relation to the underside of the box or the housing. So that's measuring 90.62 in the bore. So divided that by half, that gives me 35.31. I know the unmachined height from the underside of the housing to the center line is 80 millimeters. That comes back to 79 millimeters after we take a mill off the bottom, but in the unmachined state it's 80 millimeters. So subtract 80 millimeters from the 45.31 and we end up with 34.69. So from the top of the parallel to the bottom of the bore should be 34.69. I'm getting 34.67, so you know that's within a whisker of what I need it to be. So I'm fairly confident that I can clock up to that bore and be fairly concentric when we bore through to set the positioning for that compensating plate to weld onto the back. So we'll go ahead and get set up, and I'll show you how we're going to go about cutting that back end out and then boring it through. Alright, so I've got the housing, this little gearbox housing, mounted up on a couple of parallels. I've got that sitting up against one of my tenons. We need to put the hole in the back end of this little housing where that compensating ring is going to go. And as I mentioned, we're going to align it off that diameter there to sink through. So I'm going to sink it through with one of these hole saws, bimetal hole saws. And then we'll open up with a boring bar and we'll see how we go. I'm going to try something first, something I've never done. Well, I've always wanted to try it and test it out, but I use these little edge finders for finding the centres of holes. And I wouldn't mind just seeing how accurate they are. So I'm going to do it with the edge finder first, and then I'll set up my my little indicator, and we'll run that around and just see how close it is. Alright, so I run my machine at about 1000 RPM when I'm doing these little touch-offs. So I just press my half function on my digital readout, and it gets me to where the centre should be, which is basically right there. Right. I'll do the external next. So we're using the edge finder. That should be dead center. So I'll wind that down and we'll set up the little test indicator. And there's my wife with coffee. Oh yes, can't live without coffee. I think it gets me up in the morning. Right. So I'll just get a little, just grab my little mirror. I'll tell you what they are as we go around. off just a touch. Now, this may have pulled a little bit too, obviously, when we put that heat in there with the welding, but alright, so it's within 0.1. It's back to 0. And over here, 0.1. So yes, it has elongated out like this. So it's 0.1 high here. If I come around the other way, goes to 0, goes 0.1 the opposite way. So it is concentric, and that little wobbler was pretty spot on. Even though the hole's no longer round, 0 there, 0.1 of a mil down there, back to 0 there, and 0.1 of a mil high there. So it has just elongated out. Alright, so I'm happy with that. That's a start. We'll get this centered, we'll get this hole saw organised, and we'll drill down. Alright, so I've got the hole saw set up. I'll run at a faster speed. It's a 6mm bit that's in there. We'll get that through first, then we'll drop the speed down to get this thing on the go. Can't get that any time the way that is. Had to pack it off for the drive dogs. So we'll just take it easy. We'll get this hole drilled in first. One of the main reasons I've got this up off the parallels is so that when the pilot drill goes through, it ain't going to drill into my table. Alright, we'll just go into a back gear there. I'll run it in reverse in back gear. Up in there. Right, so that's our disc cut out, and we'll set up for boring it now. So we'll get this apart, get the boring head in, and we'll get ready to give that a look out. Well, that was an expensive exercise. When that hole saw cutter grabbed, it's actually jammed up inside. It smashed the jaws inside, and it's also smashed the keeper plate at the back. So yeah, it's pretty stuffed. All right, so I'll have to look at getting a new one of these. Ah, the joys of it, isn't it? Alright. Anyway, can't dwell on that. Right, let's get set up and we'll get ready for boring this through anyway. And we'll get that back place finished off. Alright, so I've put my my boring and facing head in. I've got this extended tool which allows me to get right down inside and machine through to the back. So I've already taken a few cuts. I've only got a little bit more to go on this. I'm just poking my ruler in inside. I want to come out to 66 at the moment. I'm just shy of 55 there. So if I wanted to get this more accurately, which is what I have to do down the track when I do bore this, I'll have to move this zero my digi readout out, move it out of the way, drop down with my bore gauges, measure it, and then bring it back again, and just do it incrementally until I get that out to size. So that's if I do it this way. The other way is I'll set up the big lathe headstock extender in the lathe, and we'll do it in a 4-jaw. But this is working out alright at the moment anyway. So we'll get back into it. Quite a long tool, bit of vibration there. It's not too bad. Just got to take it easy and don't go overboard with it. Exercise for the day. Right. Remember back here. Right, I might take you back a little bit. We'll do another cut and we'll show you the hand wheel operation on this and the engagement. There's the hand wheel motion. Before we go on, I thought I might show you one of my, I guess you call it failed experiments. This was a slotting attachment that I made up to bolt down onto the saddle. I've got some mounting holes in my saddle, so fairly substantial. I used a 75mm diameter boring bar, which I've registered up inside this this block. And I've got a nice big thrust key that would butt up against the side of the saddle. Another big thrust key at the back there. So I had this this mounted up on the saddle and cranking it backwards and forwards, basically racking it using the saddle wheel, and even with, you know, a 3mm, is that 5mm? It's a 5mm keyway in there. Even with a 5mm key, you could feel it starting to struggle and strain on that rack and pinion. It was part of the hand wheel for the saddle. So the idea of this was that I could set this up and then adjust to actually side cutter width, but then you use the saddle to bring it back to set your depth. So that was my idea, but as I said, it just put too much of a strain on that rack and pinion on that hand wheel for the saddle. So hence I want to have a go at doing one of these little powered units. So You know, we all try little experiments, and sometimes we fail and they don't quite work out the way we expect. So anyway, it was worth a go. If it had worked, it would have been ideal, but as I said, just putting too much strain. So that's our setup there at the moment. We're going to get that set up for welding. So we'll weld the compensating ring in, so it's going to get penetration weld around the perimeter, but then I also want to get a weld inside here. This is going to be bored out, but I'd like to have that web connected into that compensating ring. So I'm going to try and get a weld all the way around inside there. Once we've got that into place, we'll then mount the tapping foot up. And I'll see how I go with my access getting in there with a weld. I might only just start here and run it out, over here and run it out, and then weld it in across the base there. So we'll see how that pans out, but I'll get this compensating ring set up first, and we'll get set up outside ready for that weldment. We'll see how we go. Alright guys, we're going to weld this compensating ring in now. So I've tacked it in place. I centralised all that up and clamped it off. Got it tacked on the outside and also on the inside as well. And I've got a bit of super wool just inside there, just to try and stop a lot of the spatter going back inside. As a matter of fact, I've melted that or shotted that out a little bit. So anyway, we'll see how we go with that. I'm going to run those with a 2.5 all the way around, and we'll get that welded off, and then we'll weld on the inside just to try and seal that right out. So alright, we'll turn the little welder on and we'll get going. Alright guys, so probably not the greatest welding in the world, but it's pretty good. But hey, I've got a lathe, I can fix that up. So that's fully welded all the way around the outside, and then we'll start doing the weld around the inside then to sort that out. My wife has bought me coffee. Usually when she buys coffee, that means I've got to sit down and we've got to talk. So I'm going to do the right thing. Alright, back soon and we'll set up and we'll do that internal weld. Righto, we've finished that welding job, and I now want to machine this radius back, or these welds back into a nice radius, and give this face a lick as well. So I've got this as concentric as I can to that larger bore on that 25mm plate up inside here. So I've got my indicator poking right up inside there, and to see the dial, I don't know if this is going to work or not, but down inside there you'll see the dial. So as I've been rotating this around, I don't know if you can see that moving at all, from point to point, it's probably going to be maybe 5th thou out, 0.1 of a millimetre. I've got that hard up against the back of the jaws there with that plate, and I'm going to give that a little lick, and then a little lick on the ID there. So we'll set up and do that now, and we'll see how we go.